Now that we have a way to see what has been clicked, we will add some more elements to the page. Then we'll make use of some other shorthand methods for adding handlers for other events. With this page, we've added two paragraph tags to the work area div. The first paragraph has the clickable class assigned. The second paragraph has an embedded span with the clickable class. We haven't made any changes to the code, we've just added more elements with the clickable class. We now have 4 items on the page that should respond to a click: the header, the input button, the first paragraph, and the embedded span within the second paragraph. Let's test it out. As expected, each element responds to the click event, and we see the node name is different. There is an unexpected consequence of our code thus far, and we need to talk about it. As programmers, we write code with certain expectations and test against those expectations. When we get the results we expect, we move along to solve the next challenge. That makes sense, right? The code works like we want. What more is there to do? Well, there is something wrong with this page. It's not broken from a coding perspective, but it will certainly cause users to scratch their heads. It can be very difficult to think beyond the immediate requirement and consider how the user will interact with our page. Programmers write code to satisfy a requirement, test that the requirement has been met, and repeat the same test every time they interact with the page. In essence, they train themselves on how to interact with the page and never deviate from that interaction. A new user approaching the page will most likely interact with the page in a much different manner. Let's look at how a user might approach the page. Let's move the mouse over the work area title. The cursor changes to a hand, just like we expect. When we click it, we get a message, just like we expect. Since we coded the page, we know there is no click handler associated with the messages header. But the user doesn't know this. It might be natural for them to move the mouse to the messages header to try to click it. As we move the cursor to the right, the cursor indicates a clickable state even when we're far to the right of the header and over white space. Once we finally move to the edge of the div, the cursor changes back to an arrow. The same thing happens for the first paragraph tag as well. If we move the mouse to the empty space at the end of the first paragraph, we see that the cursor changes to a hand. When we click in these areas, we see click messages, but the user may wonder if there is hidden content or a non-visible hotspot. More likely, they'll scoff at the sloppiness of the coder. The purpose of this video is not to debate HTML layouts. I only bring this up to illustrate how easy it is to create something that works exactly as you expect it to, but not necessarily as the user expects it to. There's often a chasm between developer and user expectations. This is a simple illustration of how that chasm is created and often ignored by the programmer. But back to our events. Now that we have more elements, let's add another event handler. Let's start with a double-click event handler. We're using chaining to continue to use the original selector that we specified. We've also formatted the code to spotlight the fact that we're using chaining. The code reads like this. Create a jQuery object array for all elements that have the clickable class. For each object in the array, attach an event handler for the click event. For each object in the array, attach an event handler for the double-click event. We can chain as many actions to the original selector as we wish. We just keep adding methods separating each with a period. Chaining methods like this makes for readable code, and it also is more efficient than asking jQuery to repeatedly find elements for the same selector. So let's see this in action. Clicking on an element still works as we expect. A double-click shows 2 click messages and a double-click message. Now that we're recognizing the double-click event, what do we do with it? Well, notice that any text that is pointed to during the double-click is highlighted. That's a feature of the browser. What if we didn't want that to happen? I mean, come on, we've obviously put so much effort into our design that we certainly don't want the browser to mess it up with random highlights. Seriously though, there may be times when we want to prevent text selection with a double-click, or even a mouse drag event. This also gives us an opportunity to talk about propagation and preventing default behavior. Here's a side note for anyone that is following along with a browser other than Firefox. The events that show up in the Messages div may differ from those that show on this screen. For instance, Internet Explorer does not fire 2-click events prior to the double-click event. Other browsers may also behave differently. The purpose of this video is not to explore those differences. If you need to know exactly what events are fired from each browser environment, you'll have to do testing for each one. We're just using Firefox for this video, so we'll stay focused on the events that it processes. When we double-clicked on the span element, we saw the browser process 2-click events prior to the double-click event. There were actually many more events that were fired prior to the double-click. We just don't have handler functions attached for them. There was a mouse move event as the mouse moved onto the element, a mouse down event, a mouse up event, then the click event fired. We then had a repeat of the mouse down, mouse up, and click events. There were probably some extraneous mouse move events scattered in there because few people hold the mouse absolutely steady in one place while clicking and double-clicking. There may have been numerous system-generated events as well. The point is, our web page generates a great deal of events, even when we're not listening to them. If we want to disable user selection of text on the screen, we need to decide which event we want to respond to and what we should do once we get notification of that event. There are many different ways to accomplish this, and we're just going to explore one for Firefox and later on another one for Internet Explorer. The intent is to discuss event handling, not to discuss every possible way to accomplish a given task. We'll talk about how to do it in Firefox and Internet Explorer because the approaches are different. First, we'll talk about Firefox. Thinking back on the list of events that were processed prior to the double click, we recall that the mouse down event is fired early in the event cycle. We could listen for that event and cancel the mouse down processing. Let's add a mouse down event handler. This handler is similar to the double click event handler. We specify a different event type for the show event message function, and we return a value of false. Why return a value at all? Neither the click nor the double click handlers did. Will returning a value from the event handler mess up our chaining? Let's start with the last point first. No, the chaining is not affected by any value returned from the event handler. Keep in mind, we're chaining the attachment of the event handler, not the actual function. Let's look closely at this syntax. The mouse down method is part of the chain of functions associated with the base selector of class name clickable. We're passing the event handler method a single parameter. In this case, we're passing an anonymous function. That function is not executed right away. It is just attached as a mouse down event handler to the element. The anonymous function will only execute when the user presses the mouse button while the cursor is over the element. That may occur once, many times, or never. The return value of false is used when the event handler is executed, not when we chain the event handlers. This is a critical point to understand. According to the W3C specifications, event handlers aren't supposed to return a value at all. This technique was introduced in Internet Explorer years ago and has been widely used ever since. Many other browsers have added support for this technique as well. Okay, so why return a value in the mouse down event handler, but not in the others? A return value is not required from the event handler. The presence of a return value of false tells the browser to cancel that event. When we return false from the mouse down event handler, we're telling the browser to stop any subsequent processing associated with that event, including the selection of text with the double click. Strangely, even though Internet Explorer was the first browser to allow the return value, it doesn't actually cancel the selection of the text on a mouse down like Firefox does. The event gets canceled, but the selection of text is not associated with a mouse down event, so it needs to be handled differently. Let's see it work in Firefox first. Notice how we get 2 mouse down events and 2 click events prior to the double click event. The header text isn't selected, however. Neither is any text within the clickable paragraph. If you're thinking this is a great way to prevent the user from selecting text on a web page, you're half right. The mouse down event handler is only attached to the clickable elements. The rest of the page ignores the mouse down event. Therefore, dragging to select and even double clicking will still work for non-clickable elements. If you really wanted to disable all selections on a web page, you would have to listen for the mouse down event on the body tag. Also, keep in mind, this won't work in Internet Explorer. We'll look at how to prevent text from being selected in Internet Explorer in a little bit. We have to talk a little bit more about event handling first. We've looked at one way to prevent default event processing, returning false. There are more direct methods available to us beyond returning a false value. We've also identified some distinct differences between Internet Explorer and other browsers when it comes to event handling.